Hi everyone, I hope you are doing well. Welcome to another tutorial of MATLAB Simulink. In this tutorial, we are going to simulate a three-phase controlled rectifier with a resistive load and a RL load. To begin with, I'll open my MATLAB Simulink. First, we should add a three-phase voltage source. No, that isn't what I was looking for. Three phase measurement, three phase source. Yes, that's right. In here I set my RMS voltage to 220 and frequency 50, and we don't need impedance. Okay, we also need a three phase VI measurement. Okay, and in here we don't need current measurement. Alright, first of all we need power GUI. Okay, and after that I'll add three thyristors. Let's delete the measurement port. Okay, it seems to be enough. Okay, let's connect our circuit blocks. Let's make it bigger so it can connect more easily. And we need an RLC branch. For the first part of our simulation, we only need resistance, which I set it to 5 ohms. So, in order to activate our thyristors, we need pulse generator. Since our frequency is 50 Hz, I set it to 0.02 seconds, which equals a cycle. And I set the pulse width to 3.33. As of my experience, it has the best, it shows us the best plots in this pulse width. And I will set the phase delay at the end of this. So let's set that our pulse generator now, so I can just copy it for other pulse generators. Our first phase delay, I want to set it for 60 degrees, so I should type our period, my phase delay, and 360 degrees, which it equals to 0.002 seconds. For the next thyristors, I should add a 120 degrees because this is a three-phase inverter and each phase has a differential of 120 degrees with the next phase. And this one we can write it 240. We also maybe could write minus 120, but I guess it maybe shows some errors. So let's connect them. And for the thyristors beneath, in here we should delay it for 180 degrees because with this differential degree we have the best situation to inject the least THD and harmonies to our network. So they'll have a differentiate of 180 degrees with the upper thyristors. Let's check. We don't change the parameters, they seem to be alright. We just check the pulse generator. Okay, the last one here should have 180 degrees delay, so it's alright. Double check, alright. So let's run our program and find out if any issues does it have. So it seems to be fine. So now let's add a current measurement. I would like to put it here. Fine. Let's add a voltage measurement. Okay, and we can observe our source voltage with this block, so we don't need to add a separate measurement for that one. We need a scope. Let's connect it. I guess it's okay. I always try to make my lines so straight. In that way, it would be I can easily recognize the errors in my circuit. And we need voltage measurements for our thyristor. I want to observe all the plot of each of their voltage of our thyristors in one plot. So I use a max block, so it enables us to observe them in only one plot. Let's connect it. Oh, it should be connected to this and this. it's alright, and I connect it to our scope. Alright, and how about add a block like this in here for these tyrants? Let's oh, we didn't connect these ports. Let me see what happened. Oh, I found out I made a mistake. I should have connected this to the cathode. Okay. And connect it to our scope. So that's great. Now let's decrease our simulation time to 1 second, and let's change it to our timing was, so now we can observe 5 cycles. So it seems we have a problem here, and that's we can solve it by adding a gain block, set its value to -1. So so now it seems to be fine. Now let's discuss this plot. As we can see here, we have our output voltage and the thyristor's voltage here. In the plot of our actually upper thyristors, the thyristors that has the voltage of its on-it is more than others directs the flow, and in the actually beneath thyristors, the one which has its cathode voltage is more negative than the others gets activated and direct the flow. So, and let's see the mean of our output voltage. Okay, we also need a display. Let's see its value. It's 255.3 and its principal is calculated this way. And if you put the values like VPIC, which was 311, and the cosine of alpha and divided to p, it equals to 255. So let's get back to our simulation. For the next part, we want to add a RL load to our circuit. So change it to RL, click on OK, and let's change its value to, let's say, 10 millihenry and change our resistance to 2 ohms. So we don't need to change other thing. Our fire actually our delta is 60 degrees, and let's see what happens here. So as you can see, we have a spectacular change in here, which this is about our output current. And as you know, the inductance prevents from immediate and instant changes in our current. So it took a little time to reach its peak. And the principle about our thyristor is the same as our previous simulation. So thanks for watching and subscribe me for more tutorials. Have a good time and goodbye.